This meeting is being recorded.
Dear participants, welcome again and very good morning to all of you and the session of the experts, Professor Ibrahim Joseph. It is with great pleasure that we extend a warm welcome to you as expert speaker in the online FDP program on smart building design being held in collaboration with Department of Architecture and Planning and Department of Mechanical Engineering, NIT Patna. We are truly honored to have you with us today to share your expertise on the vital topic net zero built from designs. Your deep knowledge and work in sustainable architecture and energy efficient design will undoubtedly enrich our understanding and inspire faculty members, researchers, and professionals to rethink how the built environment can respond to the urgent challenges and climate change and energy conservation. So once again, we warmly welcome you, sir. And now I call Subham Meena, sir, to briefly introduce the session expert to the participants. Sir.
Hello, hello, good afternoon. Hello. Hello.
Yes, sir, I can hear you.
Yes.
Yeah, I hope I can't see any of you, but I hope everybody can hear you. Can you see me also?
Yes, sir, we can see you, sir.
Okay, fine. You all had lunch?
After this session.
After this session. That means hope you will be, your stomach won't be creating so much of a problem, and let us move ahead with it, and let us try to see what is a net zero building and what is a net zero energy building and what are the other net zero type of buildings. So although the title is net zero energy buildings, what, why, and how, these are the three things I would like to discuss. So we will start with the very traditional way of approach, what is normally seen, and most of the topics will be covered, would have been covered by all the previous sessions. And let me bring you the difference in that. The first part will focus what, and then we will go to the principles of it, that is why, and then exactly how different methods can lead you to success. So let me begin. All of you know that the carbon emission is a key component that has to be linked with the net energy saving or energy use in a building. Now, this is why carbon emission is very important. Now, you will find that in the black, yellow, pale green, and pink colors, and to yellow, ochre, and gray, you will find that it is residential direct 6%, residential indirect is 11%, non-residential direct is 3%, non-residential indirect is 8%, and the building construction industry, concrete and linoleum is 6%. Estimated emission from for bricks and glass is 3%. So if you put these things together, you will find that the construction industry is significantly contributing to the global consumption and the greenhouse gas emissions for roughly 37 percentage total emissions in 2021 records of WGBC, World Green Building Council. So the remaining 63% contributions come from the transport sector, other is building and construction activities, various other industries, and additional sources. So you will find that even though 63% is left behind, it is also mainly from the transport sector and other building construction activities. So you find that in effect, total consumption goes above 60% from the construction industry itself. Now let us see the next aspect of it. This is energy weight to the building sector. So, total operational energy demand of the building sector amounts to 30%, 34%, which includes 30% building operational energy demand and 4% usage by industries and that manufacture building materials. So, if you see again the same way, the black lines, the highlighted lines, residential is 21%, non residential is 9%, and building construction industry is 4%, materials such as bricks and glass 1%, and other building construction industry is 3%. This is the UNDP report of 2022. So you will find that in all these things, the residential buildings, the building demand will be 34%. Now you have to combine, read the first slide and second slide together. First is the carbon emission, which causes greenhouse gas emissions. And you know, these greenhouse emission gas emissions are causing uh, the climate change, overheating, and all those things. The heating increases, the temperature increases from year to year, and that causes melting of ice, and then it causes flood, it causes rising in sea level. It makes the countries lose their coastal areas, and we are all finding flash floods and all these type of natural calamities which are linked to this carbon emission, which is because of energy consumption. So there is a need for transformative shift towards net zero carbon built environment to ensure the sustainable practices and minimize environmental impact. So it is bifold that net carbon built environment also ensures or contributes greatly to the net zero buildings in energy buildings. Now let us examine the net zero concept. Net zero is a term that refers to the reduction of greenhouse gas emissions generated from resource consumptions to as close to zero as possible, and the concept is applicable to all resources. Now let's see which are these resources. Net zero energy is one, net zero water is another, net zero waste is another, and net zero emissions is another. So you will find that basically solid, liquid, and gas, this is basically waste, and consumption also will be there in all these sectors. So net zero water is also important, net zero waste is also important, and net zero emissions is important. Now just for an example, if we use the energy use, space heating, space cooling, domestic hot water heating, lighting, electricity for devices and appliances and others, these are the energy uses in it. Now you find that then the energy generation is basically solar, then photovoltaics, the solar thermal and geothermal and others. Now a net zero building, uh, its energy use is satisfied over a typical year by energy generation from the renewable energy sources. Although this is the working definition of net zero, we have to consider the total amount of materials consumed by the building phase itself, and then the operational phase, and then the demolition phase. All the three phases are to be covered, which will I will introduce in the the next slides. So most important is the definition. How do you define net zero? Net zero is per year consumption energy and per year generation of energy by the building is equated so that it becomes zero. But on the contrary, there are much more aspects to be considered, many more aspects to be considered while you go ahead with the net zero concept. Now, the net zero energy building are characterized as zero and net energy consumption buildings. The total sum of energy used annually by the building is approximately equal to the total sum of the renewable energy produced on site, etc. So the figure shows here, it is showing that the total energy used in buildings and the local grid, whatever it is taking from the local grid, it is also given back to the local grid. So in a way, it is on a fulcrum, and you find that the energy use and energy consumption, this becomes net zero only when what happens, the energy used is equal to the energy produced. So you will find that the products and services are the next 2 decades. See the projection. Now, if this is 2017, 18, 2019, 2028, 2020, 25, and then projected to 2035, it's going to exponentially increase. So this, since this is exponentially increasing, why? There is development going on, huge development going on around the globe. Number one. Number two, climate is already changed, and we know that it cannot be reliable as in the older days. And we need all things to be brought back to the original state, which is called the resilience of the structure. So if a building gets vanished by flood, then that building has to be rebuilt. So this is another important aspect that you have to consider in it. So in a way, you will find that uh, we have this lacuna, the challenges, basically legislation, policies and regulations. There are no clear policies stating how exactly things are to be done. What are the penal clauses there? What are the effective, basically working like subsidies? Then the laws and regulations, awareness creation, and public education. See, many of us know, we are learned people and we know that net zero is important. But then green is also important. It was a talk of the day every time some years before. Then it came to sustainability. Now it's coming to net zero buildings. Now we are all aware of it, but what about the end users? See, for a green building, green rating systems are there. Griha is the national rating system. And if you want to get a Griha certification, you have to be, the documentation process itself is costly. The money that you have to invest on a certificate is definitely a huge amount, considerable amount, and normally normal clients will not prefer that. Moreover, that is the main reason why we are not getting that clear picture of how many buildings are green or sustainable or net zero. Now, everything requires a certificate in our life. So, are we willing to pay for the certificates, or are we going to really benefit from the strategies that we have used? This is a basic question. Any money investor will definitely look for this question. If the benefits outweigh the investments, then it is profitable. Otherwise, it is not a profitable thing. And just for a certificate, nobody will go for that. Now, finance, innovative financing plans. Say, for example, if you have a net zero building, then there is a, the finance plans are there, loans are there, the interest rate should be less. Or governmental economic support, means like subsidies and other things. You can definitely recommend substantial upfront investments and dissemination of cost information. The cost information is very important, because normally the clients always prefer the best, and they don't have the money to get it. So they finally cut short things, and then finally the product itself becomes not a real good solution for what exactly it is aimed for. So aim is one thing, final achievement is another thing. So here comes the dissemination of cost understanding. I think here the role of architects is most important. Now, the architect of the times, as you all know, uh, that they are not well aware of many of the things, that the physics behind it, or how exactly costs are varying. Say, for example, if you go, whether you should go for a double story building, the 3 story building, or 4 story building. If it is double story building, why? This is basically cost analysis. Now, you know that our beloved architect Charles Correa, he has come up with a concept called low rise high density, which is based on Fresnel squares. The principle is mathematical. So the more the perimeter you move to, the maximum area that you get, and the open spaces in and out will be there, so that the built form will be surrounded, and also the energy consumption will be lesser. So if you, and the structural investment, cost investment is much less. So this is something that the designers must contribute to, make the client aware of before he starts working on the project. Now then, technology, the technological advancements are there. Many advertisements we see, this and that benefits are there if you go for our system. But why? What are the disadvantages of it? Say, if I use a staircase with quick steps, say residential buildings does not demand 15 centimeter rise. So you can have a very short flight designed, maybe 18 the maximum you can go, and then save that space. That means any saving in space and any saving in materials is any saving in this way of designing, that which you get from the benefit that you get from the designing of the building will be reflected as energy saving itself. Energy saving is, there is an equation that energy saving is equal to energy produced. So wherever you save the energy, then it is equivalent to the energy produced, because there is no demand. This is something that architects will have to appreciate. Then building evaluation, see, you design everything, but the post occupancy evaluation of buildings in US states that the operators does not even look at the manual how to operate the building. So then how you have done everything, but if it is not done properly every day, that is the maintenance period of time or the running life of the building, then how are you going to get this goal achieved? So that's a big question. Another, then building energy technologies and design, these aspects are very very important, and technologies are available, that's one point. Number two, how you adapt the technology to the building, whether you adopt or adapt. So these are very 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 important. Say for example, you are switching off from wood to aluminum in the case of window frames. Now the window frames, wood means it has low thermal conductivity. On the contrary, aluminum is a thermal bridge. It connects the exterior to the interior, and it has a very high conductivity. So, whatever aluminum that you use is going to transmit heat into the indoors of the building or the built form, so that you will find there is a higher energy consumption. So how you adopt or adapt these technologies into your design is very very important. So then coming to the stakeholder engagement, effective stakeholder engagement, whether they are really getting into participation, or is it in a participatory mode also. Say for example, there is a 1 lakh housing scheme in Kerala, where the government of Kerala once decided at the time of Chief Minister Achutha Menon, that we will give free houses to 1 lakh people. Yes, I have gone there. I have seen that it is a well designed, good structures uh, for residential people use, and that is for the low income group people. 1 lakh houses were created. They initially they were very happy because it is given free, and that too in the city. Now after some time you find that when you go for a post occupancy, that 1 lakh housing scheme itself becomes a slum in the city. Why? Number one reason, they have not spent any money, so they have no ownership. They have not participated in its construction, so they have no ownership. So this stakeholder engagement is very very important. Driving implementation, whatever you suggest has to be implemented. Now if you put uh, an energy saving lighting device, say for example the digital lamps that you are getting now, we all know these type of bulbs, they or luminaires, they consume much less, but the cost, initial cost of that is higher, on the higher side. On, so a normal person will think, why should I spend 250 rupees and then buy that bulb? He is not looking into, and also the things are not guaranteed. Of course they will replace and all those things for a particular period of time, and all warranties limit the period to the failure time. So you find that if you are lucky you will get it replaced, otherwise you are getting lost. So the operational, the implementation of recommendation is very, very important. Similarly, project specific collaboration and policy regulation, these are other two important aspects that you have to consider in it. Now coming to cultural, this one, the resistance. See, we have a problem. We have been practicing our construction for such a long time, and it is an established process, so we trust in it. On the contrary, if I ask you to go for something different, something creative, something which will, say, for example, funicular shells. Now, funicular shells are proven, but however, a normal person will think, anyway, I am spending money. Why can't I get the best thing just as the high income group gets? Now, high income group also can use funicular shells or brick shells or brick vault and all those things. But then the question is, see, I remember a Hutco exhibition in Trivandrum held in 1985, uh, where the people were saying so many low cost buildings were made. And then finally, people were asking, where is the Hutco chairman? Is given the boarding. So he is in a five-star hotel. So then why we need to live in a low-cost house? So this is a question. And against cultural resistance, we have to definitely fight in the sense that the architect or the designer will have to take additional steps to make them aware and convinced of the requirement and the need, and then go for new or alternative methods. Public awareness is another area where you know that it is aware, we are not familiar with, but we ready to adopt it. Risk averse culture. Now we have no we have a culture where we don't take any risk. So if you get a government job, then it is fine, life is secure. Now this is our attitude. On the contrary, those who get into high investment, the risk, high risk investments, they bring a lot of money to their account. So this risk averse culture has to be understood well, and we also should venture into risk, taking risk, so that we will be benefited from that. Now we come to the different phases of the building. So here, influence of stakeholders across the building cycle, life cycle, is what I want to describe on. It is not the net zero per year calculation, but what about the whole situation? So the squares represent three, four columns are there. The one is construction, second is use stage, where is operational and use stage embodied, and carbon emissions are also there, and end of life. That means how are you going to use the built materials, build already built materials? Will it return to reuse, or will it return to some sort of modification and can be used at least partly recovered? These are questions that we have to raise. So architects have a very high role in the first stage and in the last stage. Now, you will ask me why architect is important in the first stage of construction. Say this, I'll say that the construction is basically designed to construction. That complete stage is there. So any decision that architects make, uh, that is going to have a very high impact on the operational and the emission of carbon. So it is, this is very, very important. And then what material you choose, what systems you adopt, that is going to have a big say on the life, end life carbon. So this is why I say that the role of architects is very high in the beginning and the end. Then engineers, they don't have much of a say in the beginning, but then as the design moves into perfection or completion, they will be definitely much become very very important in that. And they don't have a much of a say in the final stage also. Then coming to cities, states, and regional authorities, they have low importance at the first stage, very high importance at the operational stage, and then low in the other two stages. So contractors, they have a very high influence on the construction stage, low in the operation, and low in the. Now property developers, high initially, then low, and then medium. So you will find that if you consider all these stakeholders, then we will be in a position to see how important architects are and how important engineers are, how important the contractors are, how important the developers are in the process of the making of the building. So construction, operation and maintenance, and demolition, these three phases are to be considered if you really want to get a net zero building. Now, net zero means it's not only net zero energy, net zero water, net zero waste, and similarly, you will find the net zero emissions also. So, you will have to be very, very careful, cautious. So, I would like to say that you have to maintain this attitude to net zero until otherwise you maintain the attitude to net zero until you are fully thoroughly convinced to the act and generate an attitude of net zero or green or whatever it is, you are not going to have the end result achieved. Now if you see the typical, these are 164 residential buildings are already constructed in the global distribution. So you find in India there is one somewhere here, and in Africa there are two, there in America also there are coming up many things. But you will find that of all the constructions, small residential buildings, that is the core of the construction which is going on everywhere. So residential net zero buildings are the majority and are mainly located in Europe, North America. Of course, it is coming to India also. So if sustainability is and green are more prevalent in US, you will find that more of net zero is prevalent in Europe. So this is a fact. But then you have to find what is the essential difference between net zero and green and sustainable. So this is a question that we need to address philosophically first, and then systematically broken down, and then you will have to do a value analysis of each of these things, and then only you will be in a position to proceed with the net zero building and then achieve the net zero goal. Now, you might ask why this value analysis is important. Now, let me ask you a question. What is the height of a habitable room? You will definitely say NBC says 2.75, but for air conditioned it is 2.4. But do you think any of the buildings recently you visited having just 2.4 meters clear height? No, they are all very, very tall buildings, and tall, clear floor to floor height is given so that ducts can be accommodated, wiring can be accommodated, plumbing can be accommodated. All these things comes into play. The systems of communication comes into play. The structural system that you adopt is also going to have a very, very clear influence on the room height. Say for example, if you use a steel structure or if you go for a concrete structure for a span of 6 or 6.5 meters, then you will find the depth of beam is different in the two material cases. Steel will have a shorter or depth, on the concrete, concrete will have a deeper depth. So that means your building height also increases accordingly. Say, look at the construction of 20-storied building. 20 storied into just 10 centimeter makes it almost 2 meter. That means another floor could have been constructed if you reduced carefully that 15 centimeter or 10 centimeter from each of the floors. Now, this takes us back to our old lesson, the volumetric analysis, space analysis, then height, how much height is to be given. Now, here is the question of value analysis. Now, if you increase the total room volume, definitely the air conditioning cost will increase, but you have a different feel in a room having higher height, room height. So you have to take a trade off between the two. What are the advantages? What are the disadvantages? Now, by weighing the merits and demerits and your budget considerations, you have to do a total good value analysis. Then only you will have to look for the materials. You will have to go for the choices of heights and dimensions and all these things and the tolerances. See, normally tolerances are acceptable deviations, and if you go for acceptable deviations very large, then also your building is going to be in low quality. But then your tolerances are to be reduced to acceptable levels so that your investment in the whole of the building becomes very, very efficient. Let me go forward. If you want to ask any questions, that also is permitted. Otherwise, I'll finish it and then you will get time for your questions. Now, broad design considerations of net zero goals. As I told you, net zero site energy, net zero source energy, net zero energy cost, net zero energy emissions. What are the design principles? Design for comfort and function, airtight buildings, building enclosure. Why airtight? If it is air conditioner, then leakage is a villain. Whatever air that comes through, that is going to affect the cooling efficiency of the build of the interior. And the moment the cooling efficiency is reduced, the consumption of electricity is going to be on the higher side. Controlled ventilation. See, you don't need so many air changes which are not really required. Now, if you want to have air changes, number of changes, air changes more, it is good, fresh and fine. But then you need to strike a balance, whether you need the right amount or are you going to exceed that. And the codes are coming to your help here. So insulation that exceeds present energy code requirements are not needed. An insulation what which is prescribed in the codes are all what is, but then how you can increase the insulation is another thing that comes under maintenance. Say for example, if even if you use raw coal for insulation in maybe in an air conditioning duct or maybe some other area where you need to have an insulation, imagine that the maintenance is poor and water starts leaking. The moment water comes into all these insulating materials, now it alter the conduction, the capacity of the material to conduct heat. That will differ, and the insulation value will also be very, very low. So control water, moisture and movement by building. Hello. Hello.
Hello. No, sir. No issue. Please continue.
Okay, fine. Controlled water and moisture movement by building enclosure, building orientation to maximize renewable energy production. See, this is something which we learn in our second year climatology classes, but they are very important. If you orient to western direction, then definitely it is going to get heated up. And you see, in spite of the greenhouse glass and greenhouse effect and all these things we studying, and it is going to affect the air conditioning cost of buildings. Why are we still preferring glass facades, style, contemporary choices? You want to match up with something that you have seen in Gulf or maybe in US or some other country. I don't know why this Gulf is using that. They have their own wonderful traditional architecture. So we will have to go back to our traditions. We will examine these aspects also. Efficient lighting, Plumbing fixtures, appliances. You know that waterless urinals are available, but how many of us use it? Use of energy modeling to identify high value improvements and project plans that contribute, that coordinate and commission systems. So we will have to look into all these aspects if we really want to go ahead with the net zero goals. Moving ahead, you will find that the method to achieve the residential net zero buildings is energy infrastructure connections, renewable energy sources, and energy efficiency means. Now, electrical grid gaps, you will have to find out. Then district heating systems or cooling system, then biomass, and all these aspects will come to energy infrastructure. And then you have got renewable energy sources, which are basically solar PV, wind turbines, biomass, and then the site renewable power, purchase of site renewable power. And energy efficiency means is basically building design, efficient HVAC, efficient appliances, efficient controls, efficient occupant behavior. Say why the occupant behavior is important. This is something that you have to think about. Now see, when you have a building which is air conditioned, how many of us do not close the rooms properly? We just think, okay, fine, let the AC run, I can afford it. But if you look at, take that attitude, how many of you switch off the fans when we come out of the room? How many of you switch off the bulbs when we come out of the room? These are all called the behavioral aspects of it. The human behavior is very, very important. If they have an attitude for sustainability or net zero, then only they will be in a position to save all these phases where energy is wasted. And as I already told you, uh, energy saved is energy produced. So the building sector in India is growing at a rapid pace, which we all know, and we are projecting 60% of our development will happen in the cities. Greenhouse buildings have demonstrated that about 25 to 30% reduction in energy consumption with respect to national baselines can be achieved by implementing energy efficient practices and technologies. Look, there isn't something very, very, very scientific here. It is basically adopting the already existing tools and techniques. It is adopting our cultural practices. It is adopting our heritage architectural principles in it, learning from it, and then apply that sensibly so that energy performance can be increased, energy efficient building envelope can be brought in, air conditioning can be reduced, lighting is appropriate, appliances that which are appropriate, thermal comfort not for highly cooled places but for achieving thermal comfort. Then you go for the renewable energy. Wherever the energy can be renewed, you will have to go for it. These are some of the principles that will go into. Now, energy performance index ratio, it is actual energy performance index divided by the design energy performance index. So this ratio has to be maintained. So net zero energy means it will get a credit which is 80 percentage best practices, and net zero energy 80 and above will go to outstanding performance. So you know there is a you have ECBC code, that is something which you can refer to. Now you will find that the credit point distribution is site selection planning 14 to 16, water efficiency 18 to 20, energy efficiency 25 to 28, materials and resources 10 to 12, indoor environmental quality 14 to 16, innovation and design process 5 to 7. Now all these points are there, credits are there, but site selection and planning, let us take that one single aspect. See, many of the sites that we get have features in it. These features, some are useful, some are not useful. Say, for example, there are large existing trees. Now we have to learn to preserve these existing trees. we will not remove. Say if it is one coconut tree or something which will grow faster, it's fine. Bamboo, you can take it, use it, and it will come fast later. It will replenish. So if that site is in such a position that it has got more advantageous things, then please make use of those advantages in terms of planning your residential built forms or built forms generally. And of course, we are concentrating on residential built forms. Now, on the contrary, if you have something like a stepped type of a building, the normal approach is to go for cut and fill. But if you can make your design itself as without disturbing the site, that means along the contours, which is the principle that we use. If you use it carefully, then you will find that the cut and fill will be much less, and you will be in a position to go ahead with a better energy efficiency. So I have recently been in the board of selection for the new IAM Bangalore. It's coming up. So you will find that they have a huge 20% credits given to sustainability practices, which architects are to prove before they go into the detailed design. What is the strategy that you are going to adopt? And what the strategy you will have to explain by way of detailed design later on. So net zero is not simply something unachievable. Net zero is achievable provided our attitude is favorable for that. Now look at this one. These are not certified buildings. This is the Humanscapes Habitat Urban Living, Auroville, Tamil Nadu. See, they don't need a certificate for it, but they are almost net zero buildings. You will find that here the vault is used, brick vault is used, and you need a plastering over it, and then the brick vault is ready. Why do we need other type of construction where use a lot of concrete? Instead of concrete, then you have mud brick walls, compressed, stabilized. Mud is a very good quality earth is available there, and Arrow makes use of that. So you will find that all these are basic things, and very minimalistic attitude is adopted all around. See, each of these shells will exert a thrust here, so you need a ring beam all around it, and the same ring beam is extended as roof extension. So you will find that multiple roles are assigned to structural elements, built forms, such a way that you can avoid duplication of materials as well as structures. So it's a community house, and you will find that exposed brick, concrete, local building materials, kadapa stone, natural stone flooring. So they haven't gone for very high-end tiles. They haven't gone for probably steel doors. They have gone for that quality of wood which is available there, which is good for the construction, that is used there. So you will find that. And then open courtyards, some way of living. Here you will notice that accessibility is reduced by the steps. Of course, it is a community housing, then you will find that, and accessibility is very important, and you have to comply with the age friendliness aspect of the building also. That only you can go for the complete satisfaction of the users. So strategies: zero discharge of water, reduction, recycling of solid waste, and drought resistant crops and other things, local and endemic species for the landscaping, growing organic food. So these are some of the strategies they use. They grow their own food. They use the materials from the site itself. That means there is no transportation cost and no air pollution. So you find that it becomes more or less equivalent to a net zero building. Now look at the site design itself. You don't find, say if it is a PWD building, all around the building will be roads, tar macadam and roads. So black surfaces, they will absorb heat, and the temperature becomes almost 65 to 70 degrees Celsius. Imagine the amount of heat that goes in, which is called the heat sink, and then in the evening when the sun is set, all this heat is going to get back to the building. It makes the building enclosure very, very hot. Hello? Hello?
Yes,
Is
sir.
there any problem?
No, sir.
Okay, fine. So you will notice that the site itself is designed so that the heat intake onto the ground itself is reduced, surrounding area is reduced. You will find more of green, more of brick and other things, which will reduce the thermal capacity and also the reflection of light from the surrounding into the interior. Now this simple aspect itself can be taken into a little bit of detail. Say for example, we all know that water is cooling because there is evaporation. If there is wind, if there is no wind, what will happen? The cooling also will reduce. So what do? You use the jets or fountains. Now, what type of a fountain? The more jet it goes, the more power, more electricity consumption. So bubble fountains, on the contrary, like what is seen in Mughal gardens, the chadas, and you will find that simply water from a level is flown over pebbles, and these pebbles will cause that aeration and cooling will happen. So it's a passive technology. But instead of passive technology, if you use an active technology, which is fountains, and then that's going to be affecting the entire the electricity consumption of it. This is one simple example that I can bring in. And see, if you look at the Mughal gardens, you will see the Thuja orientalis trees, the conical shaped trees, are used effectively to direct wind to the trellis. The trellis is basically made of marble. Marble is high thermal capacity materials. When the wind passes through this high thermal capacity trellis work, it gets cooled and the cool air comes into the interior. See how effectively they have thought about it. Without the use of any active energy, they have gone for principles that are basic and sensible, so that they are sensitive to things. So sensitivity is very important and sensibility is important. That will lead to sustainability. So you will find that some of those principles are adopted here. Now I want to go a bit more deeper into it. Imagine that you have a pool of water on the western side of a glazed wall. Glazed wall is there on western side, that itself is wrong, and the pool is also there on the western side. Now the pool, if the light comes onto it, the angle of incidence, there is a critical angle. After the critical angle, it gets reflect just as mirror into that, will keep additional radiation to the inside, and then the interior temperature will be brought up. So you did not consult the climatology books. You did not study the behavior of light and water. You did not know about your critical angle. So these are the things that our students must know and appreciate, so that they can apply the basic principles of optics. They can understand the building physics principles better. They can then choose a little bit of sensible choices of trees. So you find that if you go for the exotic type of trees, now then that exotic type of trees will also require exotic treatments, which will be very, very costly. You need a gardener, you need other supporting structures, you need probably more water for it, or maybe like eucalyptus, it will dry off the land. So all these are the bad effects of trees and good effects of trees. So one has to understand. Similarly, the spread of the tree. Now if you have a large banyan tree like thing, then the advantage is that maximum oxygen is produced by the banyan trees. Spread is huge. Ground is not getting heated up because it has to go through the a layer of leaves, which will go for evaporation, and then you will have almost 3 to 4 degrees Celsius less in under the tree, and than the just outside areas. See how beneficial it is. It is good for people, it is good for your building, it's good for your site. So if you consider these aspects, say just another thing, white colors, the use of white colors on the roof. You know that roof is the major aspect of heat coming into the house or the built form. Now the roof is exposed to sun, radiant energy, conductive energy, convective energy. All these things will happen. The heat will get into convection, conduction, radiation. Now, now if you just know the behavior of this white surface, it has higher reflections. Reflection is more. So that means the incident is there, reflected will be more. That means all what heat available for transmission into the interior is lesser. So if you paint simply before the summer starts or at the outset of the summer, you just paint your roof with simple. See, what you really require is a broom and some white cement. If you use this broom, you can do it. You don't need somebody else. If there is a husband and wife, both of them can get engaged in it, and you can paint the roof with a simple white surface. That is, buy some white cement and then apply it on the roof. If you can't, then engage a laborer for that. And we don't need any finish, a high quality finish, and all those things. What we want is a color, and the color, if it is white, the reflectivity will be very high. So that's a simple way, and it will reduce to 20 to 25% of the heat in your first floor where the roof gets exposed to the sun. Now, let's go further. There is Humanscapes Habitat Urban Living, Auroville, Tamil Nadu. It's the same building, but you will again notice the points that I have said. Now you will find these facades. Just see all everywhere you have a projecting canopy. Canopy is very important, and just because you have clean forms, you will not get a good architecture. Fenestrations are required, shading is required, and of course you have patterns which are brought in because of the type of technology that you used gets you into a newer type of elevation. See, you don't need to work for it, but you have to make careful choices for it. So the techniques they have used is basically solar passive building design, integration of water, energy, waste planning, then clean mobility options, co-housing concept of living, light and ventilation, local materials. Now, see, coming to co-housing. See, for example, if I have my bedroom, my living room, and my kitchen and all those things. See, I am not using the kitchen every time. See, two families or three families, they can share the same kitchen. This is our old joint family concept. To be so many rooms are there, and the rooms are allotted to people, and the people have a kitchen there. Basic food is served. Rest of the things, if you want to make a bullseye or if you want to make an egg fry, you can go and cook it on your own. The kitchen is for everybody, and they can definitely get the basic meal. But at the same time, if you want to cook something, that can be done by yourself. If you extend that, if two families or three families sharing the same kitchen, the investment is only one, but it is shared. So co-housing is something that you have to promote. But here again, as I told, there are level differences created. It is good for interaction, community sitting, performances, and all those things fine. But it also affects the age friendliness of the campus. Now, if you use a step, then wheelchairs cannot move on that. And if you use grass, that is also difficult for wheelchairs. So you have to go for maybe a combination of perforated grass and the bricks, perforated bricks with grass cover. So that will be also encouraging water to penetrate, and that will be the infiltration will be more, the penetration percolation will be more, and water availability will be more, and you will also will be saving on the water. So it is not something very cosmetic and cosmic. It is something very sensible, pragmatic, and appropriate. And it is an attitude. So if you keep that attitude valued very high, then constructing and operating net zero buildings is not a far dream, distant dream. It is something which you can achieve. Now, this is residential net zero buildings in India. It is St. Andrews Girls Hostel in Gurugram. Now, see, one thing that I just wanted to tell, this is you have a completely double passages. So you will find that, of course, it is lit and ventilated. Here also you find there is a veranda. So the skin is protected by another skin which is exposed, and then all these things, air breeze will be there, it is airy, and then it is also shaded. Now just look at the traditional English buildings, wherever you are, whether in Bihar or in Kerala, they have gone for protect the same principle they have adopted there. Now, if you look at the Kerala architecture, there also you will find a clean veranda, all around the built form. So you will find that the built form is not directly exposed to the sun, wind, and rain, but on the contrary, there is a veranda to protect it, and that means the amount of energy required to maintain that building is far less. Let's go quickly. You can see here the double verandas. So you can see here it is pergolas. It is, if you wish you can cover them, but then this is already aerated. It is end to end open. So you will find that the entrance foyer and the lobby face to the west, but then it is open. Double height indoor and outdoor spaces to interactions and social activities. Then double skin facade. This is called the double skin facade. Now, is this double skin facade, you may think it is going to increase the cost of construction. No, you see that they have used very basic ordinary materials for it, and that is very critical use of it. So that instead of glass and steel handrails, they have gone for simple brick slab with a joint suitably designed. So you get something here. All the beams are exposed. Now, see, exposed surfaces. You see everywhere there is a shadow. There is a play of light, and you have enough ventilations. And the flooring is also not that costly. That which is available looks like the Kadapa stones. So you find that in effect, the building form is sensible. Now, this sensibility is very important. As I told you, it should be pragmatic, sensible, and you must be sensitive to things and keep that attitude of net zero in. Now, let us see net zero built forms, design parameters. Passive design parameters are azimuth, angle, the windows status, exterior wall, thermal insulation, exterior wall, solar absorbance, and then the roof thermal insulation, roof solar absorbance, and then wall window ratio, window types, overlapping projections. Now, this overlapping projection, I explained. Everywhere you can go for explanation, but we may not be able to cover the full lecture then. That's why I'm limiting and giving you an example. This absorption is very important, solar absorption, which we dealt with already by improving the properties by the use of white colors. We have already explained. Now, overhang and projection. Overhang projection, basically what is it? You imagine an umbrella over your structure. That is the overhanging projection. That means your structure is all protected, and everywhere, even brick can be overhang bricks. See, when you put the brick projected out of the wall, alternatively you will get a self shaded wall. And self shading of the walls means it is already protected from the direct the radiant energy direct coming onto the brick. So that means it is already in shade. Only thing is small shades cover the entire surface of the brick wall, and such type of built walls will have less of exposure to solar energy, and therefore it becomes more cooled in that process. So the aspects you have to think about is site selection, building orientation, building form, cool roofing, fenestrations, and ventilation. Now look at the built form distribution. See, you will find heating, only heating, and you will find the color coding there. I'm not going to explain it further. So you will find that different types of attitudes are already taken, adopted in different areas. So if you look at the African situation, they have all passive type of technologies getting into, and you will find that they learn from the nature a lot, and they also go for adopting such techniques, which is you will study now as biomimicry, which I will come to it later. Now site selection, which are the factors you will look for? Solar energy, radiation, climatic effects, accessibility, population density, green space availability, proximity to renewable energy sources and materials. So heat gain, if you want to reduce, the orientation is important. Mapping of land surfaces and temperature important. Evaluation of transportation networks and connectivity, because transportation is important. Calculation of population density in urban districts, that leads to different services and all assessments. Now assessment of park, gardens, and green infrastructure. You know that there is something called the urban heat island. So if you want to mitigate the urban heat island, then the amount of this green surfaces must be more, green and blue surfaces must be more. Coming to the other site selection and development, protecting sensitive sites, preserving undeveloped sites, say like green fields, brown fields, gray fields, etc. Then restoring and reusing previously developed sites, retaining soil in place, stockpiling and, reusing soils, etc. I'll give you a simple example to illustrate that. I was designing the master planning of the Andhra Pradesh, NIT Andhra Pradesh. So Karaikudi or something like that. That place I don't remember, but you know that was an old airfield. So my intention was to keep the runway as it is as the main thoroughfare, and then build your building so that you can save a lot of money from the roads and other aspects of it, and then you will get an axial design also for the buildings. And it was working quite well. I designed the build forms also and then presented there. They accepted it, but then it came the central PWD. When the central PWD came, they brought in their own zigzag forms of design and all fancy shapes and materials and all those things. See, the interest lies elsewhere, not in net zero. Interest lies in profits. The profits, in whatever form, I don't want to elaborate on that, is is something that bends your mind away from net zero. So instead of upholding the net zero and the national interest, people try to make good of their self-centeredness and what you call the possession, the need for possessions are corrupting the minds of people. So if a contractor does not do the work correctly up to the design detailing, then you are going to have a problem. If the gaps are not sealed properly, then their conditioning will be affected. So the quality of work, sensibility, sensitivity, and the performance, it is very important. The implementation of standards, implementation of prescription, implementation of specifications, these are also very important in achieving it. Now here the building orientation we are seeing. Now if you just orient for south, then you will get lot of energy. If on the contrary on the northern side there isn't such incidence of solar energy. Now sizing, see, you know, say for example sphere has got maximum volume and smallest surface area. Can you use that mathematical principle to design something? Buckminster Fuller used it. So floating cities he designed with the Fuller domes. Now similarly, circle gives you maximum area and minimum perimeter. That means material consumption will be directly affected. You will get, now these are concepts. These concepts are to be appropriated into your design. Fresnel squares, as I told you, one square is there and within that is the site, means you have to bring to the periphery the thing, the buildings, and then you have an interior and exterior landform where you can have plants and other things. So, in effect, what I am saying is your built form should not be exposed to the weathering aspects of the aspects of weathering. On the contrary, you can have a total projection over it and then shield the whole building. Otherwise, you will have to do it later on when your roof leak starts leaking. You will have to put another roof. This aspect ratio, therefore, is very important, and a little bit of mathematical understanding can take you to different aspect ratio. Now, aspect ratio can be augmented for the flow of air and also for the exposure of the building to the environmental factors. So, the aspect ratio is very, very important. Similarly, aspect ratio, when you consider the aspect ratio, also think about the wall. What is it made of? Is it again glass? Then it is going to be a hot oven inside. You must understand that and appreciate that and tell the clients to go for something which is good for achieving your net zero goals. Now, similarly, the built form design. See, if I design the building like this, I have more of an area, at the same time it is landscaped, and then the exposure to environmental elements are less. Now here it becomes two blunt blocks, and you have a tree, whatever it is, but it is, the exposure is there. So the angle of exposure, this one, the threshold is 18 degrees, enclosure angle of enclosure 45 is equally covering both sides. Now, if you want wind flow, it must be 2h. If this is height, then this has to be 2, at least 1.5h should be given, that the spacing between the. Are we looking for it? Are we considering this as these aspects in it? So this is something which we need to consider in when you design for the building efficiency, energy efficiency. So, building shape should be as compact as possible. At the same time, it should be also promoting ventilation. It should be also promoting maximum amount of views available, which will refresh your minds. And that means the building becomes not a simple enclosure, but it becomes a habitable space where people are happier, healthier, smarter, and they will be in a position to enjoy the building. So if you want to calculate the heat loss form factor, then there is an equation given here. Different models are shown here. You can probably work out on these things just to help out your assessment in that. Your instructors will take this slide and then try to give you a problem based on this. Then you will find out how much it is these equations are valuable. Now, just for a simple example, I'll give you a 400 square meter building. Just design the height of the floor to floor height, whether it is 3 meters, whether it is 3.15, whether it is 2.75. You work out the amount of materials required for the periphery walls only. Simple building. Don't go for inside connections and partitions. Just the 400 square meter residential built form. 400 square meter is reasonably higher income group building. So you will find that the amount of bricks and other thing, mortar and all, plastering, ventilation, lighting, all these things are going to be different. So you will find that in effect, working out the heights itself is a very, very important step in obtaining your net zero building goal. Now you will find that there are so many principles. See, cool roof, green roofs, these are all traditional way of protecting with reducing conduction. Now you can have a cool roof. Maybe it is water, or maybe it is if it is exposed white surface, roof ponding, so many things. And you can also go on making the internal air sealing surfaces measured for temperature for pre and post application. You will find that the upper temperature, if it was pre like this, the upper temperature has come down at least by to 10 percentage of 10 to 20 percentage. You will find the difference. Now, when you say cold roofing, there is urban farming. This is some one concept which I wanted to introduce to you, where you cultivate whatever your vegetables, whatever things that you want on the roof. Now it has got double advantage. You have your vegetable, and at the same time you have your cool roof also. Now it has got lot of, say for example, if there is a old father and mother, aged people there, they can go up and maintain and all those things. Children can go up and enjoy, take part in it. There is more of activity. See, the problem is no engagements for children, and they go on using the WhatsApp and other things. And I don't know what is Instagram. All those things are there, spoiling their time. And they say, finally, in the end, I don't have time, mummy. I don't have time to do that and this. Why you don't have time? Because you are using it. Time is constant for everybody, 24 hours God has given, but this 24 hours, how you use is very important. So if you go for a green roof with a urban farming, or you can call it roof farming for the simple simplicity's sake, and then you will find that these farms, roof farms or urban farms, are very good. And wherever the consumption is, there the production is. Where the production is, if the consumption is also there, then there is no transportation cost involved in this, no pollution, no energy. See, look, your dependence on other forms of energy, maintenance, and all those things are reduced. I'm sorry. So then this is a another residential build form. See, it is designed in the southern orientation to catch maximum sunlight. And but then you have to consider where in the globe you are. That depends upon the positioning of the sun. The sun path diagram is for your help, and then use of that, so that you will be able to catch maximum energy. Now if you keep this is also open here, also a little bit of open here, is it is already open, you will end up in the tube house principle. The tube house is a house form that sucks in air. That means there is always air movement. So you can explore this principle to the benefit of obtaining a net zero building. Now, net zero built forms. See, so many aspects are there. See, it is coming solar radiation, heat reflected, absorbed, transmitted, re-radiated inside. So direct transmission inside. All these can be sorted out by way of planting trees, going for projections. Now glazing made of, say for example, this is considered, this is RCC sunshade, and this is a something like a low thermal capacity material like louvers. See, the advantage is that the louvers permit airflow, and also the thermal storage, heat storage here on the sunshade is reduced. That means in the evening time there is no heat availability at close proximity to the inside. Your inside will be cooler. But on the contrary, if it is a RCC sunshade, the heat is right at the window. Whenever air flows inside, the heat is also is going to be brought in. So these are simple things, but you have to keep notice of all these simple things. Different types of net zero, see, movable shading, fixed shading, all those things are available. So go for the technology which is best suiting you, for which awareness is very important, for which the architect must be well aware, for which the architect must attend conferences and all these material exhibitions and all those things. He must have his own building material library, so that he can, and he should understand the process behind it. It is not recommending green glass or reflecting glass. It is recommending with a purpose. You know that our own Charles Correa made a LIC building in Connaught Place with reflective glass facade, and it had to be removed because it was causing so much of environmental reflection, and people met with accident, drivers met with accidents because of the reflection, painful glare coming into their eyes, and finally it had to be removed. See, great people also can make mistakes. We also make mistakes. So mistake is not the thing. The point is, to the extent possible, you do the truthful analysis and go for a value engineered solution so that your cost will be brought lower, and at the same time you keep the attitude for net zero. Then it is possible to achieve your net zero building forms. Now, triple bottom lines. See, for sustainability, people, profit, planet. Now, here the financial needs, it is user satisfaction, cost effectiveness, energy efficiency. So, I recommend a life cycle analysis, not simply a net zero year by year, but total life cycle, the building, how much it takes in, that much it should also produce, that much also it should reduce, so that energy that which is not consumed is energy that which is produced. So this principle of three pillars is very, very important. Now, coming to the appropriate space analysis, see, all these things are there. Now, if you put two buildings, this is going to be highly reflective, this place, and urban heat island formation is possible potentially, until and otherwise you go for thorough ventilation. So, height, length, breadth, volume, aspect ratio, and volumetric analysis are very, very important, and these are some of the schematic things that you can use for your technology integration with it. So form analysis is very important, volumetric analysis is very important, geometric analysis of the cityscape itself is become very important if you really want to get the overall net zero into your build forms. Now, creative approaches. Now, still now we were speaking of something where we need to invest money. Now, let us look at some of the options where you don't need to invest money. Say, for example, management principles. See, retrofit strategies with energy reduction. See, if you go for upgradation, retrofitting, then renewal is not a essential thing. That means you are not even having the need to go for a new building. That means all the matter, all the building, all the systems are conserved, only upgraded. So that is one way of doing it. Now let us look at energy side itself. Say in the early morning, say from 6 o'clock or maybe 5 o'clock onwards till 8 o'clock, you can keep all your windows open and then bring all the cool air inside the building. Then by 8 o'clock, 9 o'clock, you shut the windows. That means till the entire afternoon, your house will be cooler. And then when the insect flow stops by 7 o'clock or so, then you can put on your light bulbs and then again open the windows so that you will get fresh cool air from the outside. Now this is called the thermal management. So what is used is your energy, your attitude. There is nothing like it is a management. It's a management aspect of it. So wherever you don't want, say, double use of space, flexibility of space, these flexibility offer that it can be used for many purposes. So even if the use of the building as a commercial building is over, it can be converted into an office building, it can be converted into some other building, it can be converted into probably a bank. Look for flexibility. Flexibility brings in a lot of net zero principles into it, and flexibility is very, very important. Now, integrated design process and smart construction technology integration is there. See, anyway, you are investing in it. Why don't you go for investing in something which is giving you a total value enhancement. Value is equal to worth divided by cost. If you increase the worth of an investment, then the value of that investment will be higher. So think about it, whether it is possible for you to work on this. Post occupancy, building energy management and control interventions are most important solutions. Now, here, say for example, checking the operational manual, whether the people responsible for the operation of the building are they really functioning or not, or are they simply coming and then putting the switches off and on, and whenever they like and whenever they don't like, they don't switch it off. Or can you remove that particular person from there and fix an automatic device, sensor based device, by which whenever you pass, say motion sensors are there, they pass, then only the light will get on and off according to the use movement. So something like this you will earn a lot of profit by removing that particular person. Payment, pension, all those things are reduced. At the same time, you need a sensor based, a movement based sensing, sensor based equipment, so that that will be resolved at almost very low cost. Now, then the other methods. Think about the other methods. Building envelope design, intelligent multi species habitats. So you go for this is birds and bees and all these things put together. These are all required for us. Now we cannot think that Earth is completely ours. Earth is for other things also. We need to care for that. So design for animals is another one. Book is there. If you can go through that, you will understand that principle better. Now, you will find that alternative, see, feral surfaces, for example. Now, these are surfaces where you can plant. You can plant. That means the whole structure becomes a plant oriented building, just like the roof gardens or roof farming that we suggested. You can plant something here or in the feral surfaces, and the feral surfaces is probably you can try on the vertical surface and domical surfaces, inclined surfaces. So you will find that this is something which enhances the value, and it is modular in shape, and any geometry can be constructed out of it, and you can standardize it. And then when a particular technique has to be developed, that technology will involve the feral surfaces, which will adapt your building to the nature and its requirements. Then biomimicry, say for example, self-cleansing surfaces. You must have seen this water lilies, their leaf. They are called, all the dirt that accumulates onto the leaf, when the water rolls and make it bigger, bigger, bigger balls and rolls down, it will be carried off the surface. If the building surfaces are designed such a way that it becomes, like the self cleansing surfaces, learning from nature. So the learning from nature is called the biomimicry. So nature inspired self cleansing surfaces is one such example which I can give for. Now then the lotus effect. So this is another thing that you can look for. Conventional building exterior is predominantly composed of concrete and building coatings, then susceptible to contamination and corrosion, thus this diminishes its durability. So if you go for a self cleansing surface, self shading we have learned, now self cleansing surfaces, if the surface gets cleaned on its own, so you find that your building net zero approach itself will be uh, uh, very very effective. Now this is the case study from one of the villages here, where Bengali, I think Santhal people, they live, and what the government does and what they have done. Now this is called the Belrampur district case study. Our MR students have done this. Now number one example is this: the way they live, it's complete. for every season it is complete. A tree itself is taken care. This is a jackfruit tree, and they say that the tree is pregnant when it has got the jackfruit in it, and they take care of the tree. So you find that everything in nature is respected. Now they have the worship place here, and the path leading to that is this. Now look at the enclosure. The basic dominating material is bamboo, and the bamboo itself, they have made it into a, they carry load to the market. Children play here, and you find that even a simple bamboo cluster is made into something very, very useful. Now the pathway, everything, the ladder that they make, uh, and everything, even the compound wall, it's simply bamboo and plant. Why do we need a big compound wall? Because we have got law. We think that we are so rich and we need to protect, and we build higher and higher compound walls. Why? Is there any need? When you build a compound wall higher than 1.5 meter, then the problem is the neighbor is also affected. His right to light and ventilation is also affected. Spread of fire, you think it will be prevented, but it will be going according to the wind only. Now look at the things, that the ladder, the broom, the firewood. Now even the body scribe which you use when you bath, this is a particular fruit that they have. They just made a brush like thing out of that, just by putting it in water and removing the pulp and then drying it. So you find that everything is made of, this is mud. There's a particular type of mud with a particular composition available. It is as strong as cement itself. So you find that they have got thick sections of walls, overhangs are deep. Wherever there is a bit of a space, they have storage also made use of. Openings are there, surveillance is there, and the built form is so open. So in open non-rainy seasons, hot seasons, they cook outside, and at the same time they have got this type of ovens in the inside of the house also. That is in the veranda, and they have also veranda to protect the built form from environmental factors. So you will find that basically you can learn a lot from the traditions. You can learn a lot from uh, the whom you call the rudimentary people, or savages, or whatever it is. You are cultured, we are cultured. We look at others as they are not cultured, but they are more cultured than us. So we have to understand this aspect, study with care, observe with care, and notice what the principle they are using. And you will find that all these buildings are made out of brick, and every such cluster of houses has a central pond. Now the central pond is the place from where they obtain the clay. That means there is no transportation. The people are participants. All the peoples in the community participate in the building of everyone's house, so it becomes participatory. They have a sense of ownership in every house. So you will find that an integrated society is built up in through the construction process itself. So you find that place more livable and healthier. People have better relationship. They are happier also, and they may not be having our types of concrete houses and all those things. So emphasis is the role of cultural variables and the use of examples from diverse cultures and periods, as well as a variety of environments and resources, to allow for more valid generalizations that are possible. I have used Mughal architecture, I have used Kerala architecture, I have shown you adaptations of these traditional techniques like glory makers walls are all inspired with this trellis work, and then removal of concrete from where it is not essential, that is pillar slab. So trap bond construction, that is adding to air insulation. So all these are basic physics. Exposure of the students, understanding of the designers about the basic physics of the building, and then these are the things that will make us take us to the concept of net zero to actual reality. So, low carbon behavior, living car free, mobility, fuel efficient driving, you have different options available. Now, in the housing, less living space, low or multiple use spaces, low carbon building materials, adopting using energy efficient home appliances, then daily living, energy efficient cooking methods and cookware, avoid food wastage. See how much of food we waste. That is very very important. To produce grains, it is very very difficult. You will have to buy it with a high cost, then use energy to cook it, and then finally you waste it. Why? See, eat a bit less so that your stomach also will become comfortable. So I think we need to have this total sincere attitude of net zero so that we will be in a position to attain net zero building. So you have got circular economy, citizenship behavior, and altruistic, biastic, hedonic, and egoistic designs. For others, it is for oneself. So finally, my message is be sustainable in your attitude, be sensible, sensitive, understand the building physics, understand the traditions and the culture, and build for ourselves, not for somebody else. Build for ourselves. And thank you so much for this. And if you have any doubt, I'll try to answer. Hello.
Hello.
Yes.
Yes. Yeah. Participants, if you have any query, please ask the experts. Or if you want to any discussion regarding to your project, you are working in this area.
May I come in, Professor Singh?
Yes, Subhajit, you can go.
Yes, sir. Sir, good evening. It was a lovely presentation from your side, and it was great hearing you after a long time. Uh,
Thank you.
Sir, actually, you mentioned very correctly that it is the attitude which needs to be, I mean, incorporated and made people aware of that. So there are few
Yes.
things which I think are there, like as uh, uh, as a person has, if a client has more money, naturally what they try to do is that their house, they try to make it more and more bigger, more and more spacious, which actually reflects their social status in the society. So this is a very
Yes.
common culture that has been going through for years together, and yet which is absolutely contrary to what actually I mean, flexibility of design or multi-use of any space is there. So can we have different national policies for this, and we know that land is such a revenue that which cannot be created or generated. So it is just the optimum utilization of land. So don't you think it's the right time that there we need a national policy that a person while making a house can build up to this quantum of space with respect to the number of family members, irrespective of whatever money or whatever they have. So this type of rationing, I think, unless we go with this, this is my point of view, which I have seen, and as a professional, as a teacher, as working in the government office. So this, don't you think this is essential in today's context?
Yes, I agree totally with you, but it is a contradiction of philosophies. Now we have a democratic country. How do you say people how to use your money? So this becomes an obstacle. Now, for that obstacle, almost 20 years before, I have recommended at Goa Convention of Sound Sustainability there should be green tax. Now they
Yes.
can use their money in the way they want, but at the same time they are made responsible to through taxes and levies.
Mhm.
so that we can, that is one way. Now you know that if you just reduce your floor area to the recommended level can always be implemented. Recommended levels you can suggest, and then it becomes a benchmarking. Once the benchmarking is done, if you go 20% above up, this is the money that you will have to pay, or this is the open space that you will have to leave, or this is the amount of water you need to conserve. If you don't conserve, then you pay money. So that way, a sensible integrated way of extracting, or rather forcing them cleverly to abide with the law, is only possible in a country, democratic country like ours. On the contrary, if it is China, it can be done very easily, because authority rests with only one person.
Yeah,
So we
yeah,
have
it's
to think
socialist
of,
in nature.
see, always I link this question with see, Antilla and Ambani. See,
Right, sir.
Ambani has money. That doesn't mean that he can use the whole water of Mumbai for him.
Yes.
It's a national resource. So we need to, here in our department itself, long before professors in working in water, they say that water must be nationalized. And water, if it is nationalized, then it is, you cannot use so much of water just because you have money. And water is, if it is a national property, then it must be shared. See, rationing is important. Cuba, rationing is, they have petrol rationing is there in Cuba. You can use only this much amount of petrol, but that's possible in Cuba. But if you, in that also we can ensure here, we can give exemptions, but exemptions with accountability.
So, or maybe
Exemptions
we
with,
can have slabs. For example, if you use up to 90 LPCT of water, you pay this much of water tax. And if you go up to beyond 120, then your water tax comes 3 times. So this is something
true.
which we can, just like income tax
Huh.
slabs we have. Similarly, we can
Yes.
have for floor space index also, or maybe
Okay.
the area per person per square feet which they are constructing, or the land they are consuming.
Okay. And now, or on the other side, say like our grid, we use photovoltaics, and then we generate energy and we put it back into the grid, and the
Yes.
grid we use. So that is also possible. You contribute that amount of water, you generate that amount of water, you prove that that much is produced, but then it becomes a different type of a management for our local bodies. Now, here is the problem lies, as I told you, in NIT Andhra Pradesh example. As I told you, I work with clear conviction and straightforward honesty of my mind to use that old runway as the main passageway. It would have costed them nothing, but
Yes.
they spoiled that entire thing and they made zigzag designs. Why? For fashion. They think that that is fashion. I don't think that is fashion. You may not think that is fashion, but PWD thinks it is fashion. What to do? This is our governmental setup. We have to see, if only we teachers teach our students sincerely to practice these things, and they are the future generation for which we need to equip ourselves. I think this course is very appropriate for the times, and I really congratulate the organizers for sparing the time of such valuable time, especially with heated, a very hungry stomach, sitting here and then listening to it patiently. That itself proves the importance of this course.
Yes.
Yes.
Sir, we
Anyone
have many
else?
model towns and model areas which are coming up with different type of specific policies. Are there any type of policies? Are there anything coming up in India's policy specific to this? Has it yet come up? I don't
Well,
know actually. That's why I wanted to know.
no, no. Well, we have got different types of codes which are either prescriptive or recommendatory. Say, for example, National Building Code is not a prescriptive code, but it is a recommendatory code.
Recommended.
uh, Recommendatory, whereas our municipal laws are prescriptive. You have to follow it. Now, the government, the officials, we ourselves will have to uh, uh, influence the change makers. But then this requires a little bit of effort from our side. IAA, Council of Architecture, these people are there. What are their jobs? We need to question them. Now they debate
Exactly.
on where to hold the meeting in next time, whether it should be in Maldives or in Andaman or somewhere else. So this type of discussion should be left out, and then they should focus on the real social issues. I am telling
Exactly.
you, myself am a culprit. I was the vice chairman in Calicut 2 times, but we all discussed the same thing. We are all interested in catching the quack people and all those things, but these are not the real problems. You address the real problems of the nation, pick up the people's problems and then address it. See, in that Balrampur district which I showed you, government intervention, they gave 1.5 lakhs to these people and also gave them a plan. The government gave a plan which is to be made with cement and mortar. They are now removing the mud walls because they think that the brick and cement plastered are far better. Every high
So,
end people they use it.
ultimately, sir, it
So
is the
let me
incentive
also,
which matters.
but they have already given their feedback to us, and we are
Okay.
also bringing it out as a book and a recommendatory book. Somebody can recommend, and it is an interesting book we are coming out with. So the point is, there the people have already, the old people, especially the aged people, have already said we are finding it extremely difficult to live in this type of houses, whereas our old houses were very cool, very comfortable, and they were very happy in it.
Exactly.
Uh, and
Thank you, sir.
and
Thank you
that
so much for sharing
and
all these insights.
Yeah, sustainability assessment is something that we have to study, and the proper sustainability, not for getting a PhD. That is not the point here. Yeah, you can get a PhD also when you do it sensibly. There is a book on sustainable building assessment of built forms published by Tyler and Francis. I can send you the link of it later on.
Sure, sir.
Uh, yeah, so I think you can also get assessment. Yeah. Any other?
Sir, what is the like net zero solutions for uh, like with building with more ground coverage in urban areas?
Building with more ground coverage in urban area. Means what do you really mean by that?
Like there is a very less space available for open areas, uh, and kind of those things. Very-
You are Shashidhar Reddy?
Yes, sir.
Okay. You're from which college?
Gopalan School of Architecture, Bangalore.
Bangalore. Okay. Bangalore itself is a fine example. You are suffering now. Earlier it was the coolest city, air conditioned city, isn't it? Now development came. They left no space for greeneries. Finally, now you are getting heated up, isn't it?
Yes, sir.
Am I right or wrong?
True, sir.
Okay. Now there is no city where you don't have space for open spaces. See, our Corbusian model, if you accept, then there is, it's a single tower which can always have a lot of other spaces. Your footprint you reduce, the maximum you go up. That is one simple solution which Le Corbusier demonstrated to us. Charles Correa gave us a solution which is low rise and high density, which is contrary to that. And even your roof can be converted into roof gardens. That is itself in an open place and covered space, green space. So this is why I tell you. See, here in Bengal, if you go to the Sandal houses, they all put their melons, uh, like watermelons and things like that, or pumpkins. They grow it on the roof so that over and above the thatched roof, they get a leaf shade also. See how sensible these people are. And we cannot adopt that roof farming strategy to our cities. And cities is, it is very essential. which is called urban forestry or urban farming. It's coming up in a big way. It's not a new concept. Almost 15 years before this was introduced in the US. Now we are thinking of people, Chinese designs are coming up with all building forest. But there are other consequences also for it. We will have another class for it. But you are very correct in the sense that there is no urban area where you cannot find no place for open spaces. That means you can find always open spaces. Now you know the the development rights can be transferred.
Yes, sir. TDR.
TDR, transfer of development rights. So if you don't develop, if you give this much of open area, then you can go higher, or maybe in some other place you will get your development right. So there are so many interventions, management interventions, policy interventions which we can think of. Definitely, architects Sridhar Reddy, you will definitely work with your students. They are the best minds, and they will come up with lot of interesting solutions.
Okay,
Thank you.
in thermal aspect, this is fine, sir. But in daylighting factor, because of this compact buildings, in daytime also we need to use this artificial lighting.
Compact building means the building depth is small, or depth is short, which means that daylighting is better, much better. If it is a large span building, then only it will become necessary to use artificial illumination. And there are so many ways by which you can improve the internal lighting, passive ways. So
Thank you.
I think if you want, probably I can give you a big lecture on that. But you just refer some of the books, and you can be in touch with me if you want, and I will try to send you some notes on that.
Can I have your email ID in chat box, sir?
Well, chat box. Where is chat box? Uh, where is this stuff coming? I don't direct chat. If you can tell me where it is, I haven't used this for many purposes.
It is bottom right corner one pop-up will be there, sir.
Captions, content, and hello, sir. I got, but how to reply? Okay, fine. Are you getting it? Hello, you got it? Did you get it?
I got it, sir. Thank you.
Yeah, thank you, thank you, thank you. So, thank you, Professor Das, and all wonderful friends are there, and I thank you so much. I think the people will be also very hungry, and let's call it a day.
Thank you, sir, and thank you all the participants for today's highly informative session on net zero building from design, conducted by Professor Ibrahim George sir from IIT Kharagpur. And we are deeply grateful to Professor George for delivering a comprehensive lecture that illuminated the evolving concept of net zero buildings, and his presentation covering entire building, that's life cycle, design and construction parts, and embracing the importance of long-term sustainability. And key highlights of the session was embracing the role of architecture and conceptual integration like passive energy, energy modeling, and renewable energy system early in the design process, such as a solar photovoltaic system and solar thermal application into the building and infrastructure to meet the operational energy needs and sustainability. He also stressed on the incorporating energy efficient appliances, smart control system, and passive design strategy to drastically reduce the energy footprint from the outset. The sir has also discussed the using the low carbon and energy efficient materials, adopting smart construction techniques, and maintaining the performance through effective operational strategy. Uh, and sir is shared also valuable global insights, highlights the how country across the North America, Europe, and the other Pacific areas made progress in implementing the net zero energy buildings. And he also point out the India needs and other developing nation to align with these global benchmarks while in adapting solution to the local climates and cultural and economical liabilities. So this session has undoubtedly broadened our understandings of sustainable design and the critical shift needed in the practice, policy, and education to move towards the net zero futures. So we sincerely thanks Professor George sir for his impactful session, and thank you all the participants and their engagement. And we will look forward to seeing you in upcoming session of the FDP sir. Thank you, sir.
Thank you so much, and I wish you a wonderful lunch.
Thank you, sir, and same to you, sir.
Yeah, thank you so much. Bye.
Thank you everyone. Now we are close the meeting.
Next session will start from 4th.